Hello, welcome to this video, which shows how to create a virtual cloud network, or VCN, in Oracle Cloud Infrastructure. A VCN is a software-defined virtualized network in the Oracle Cloud Infrastructure that allows instances to communicate as if operating on a traditional network. The VCN includes components such as public and private subnets, route tables, internet gateways, DNS support, security lists, and more. When creating a compute instance, it must be associated with a subnet. So a VCN is created to provide network services to the instances. It must be configured with at least one subnet, so instances have a networking resource to use when being launched. You can find out more about VCNs and Oracle Cloud Infrastructure networking at this cloud documentation link. Creating VCNs can be done manually and with a wizard. However, in this demonstration, we will create a VCN manually and take you through the various stages to get it ready. Starting at the Oracle Cloud Infrastructure console, navigate through the main menu to Networking and then Virtual Cloud Networks. Here we would see a list of VCNs, but as there are none in this compartment yet, we will create the first one. Click Create VCN to bring up the VCN configuration dialog. We start by entering a name, MOR VCN99. You have the option of creating the VCN in another compartment if you are authorized, but we will keep our compartment name VirtDoc for this demonstration. We enter a Cider Block range which defines the available IP addresses that can be used for the VCN. Here we enter 99.0.0.0/16 for our block, which allows for a maximum number of 64,000 IP addresses. The range is defined from /16 to /30, and the same ranges can be used in separate VCNs. A VCN can have multiple non-overlapping Cider blocks that you can also add and change after you create the VCN. Regardless of the number of Cider blocks, only the maximum of 64,000 private IP addresses can be created and managed within the VCN. If we want to add more Cider blocks, we can click the Another Cider Block button, but we don't want to, so we'll leave it. If we want IPv6 addresses available to the VCN, we can check the box for Enable IPv6 Cider Block, but we don't need it, so we'll leave it unchecked. The DNS resolution feature is enabled by default, so we keep it that it will automatically use DNS to resolve hostnames on the VCN. It is better to keep this as you cannot change the setting after the VCN has been created. The DNS label is automatically generated from the VCN name, but you can replace it if you wish. And the generated DNS domain name is created using the DNS label. The Show Advanced options allows for tagging the VCN, but we will skip this for this demonstration. We click Create VCN to start provisioning the VCN. We are returned to the new VCN details page. Here we can see the compartment it belongs to, the Cider block range is assigned, the generated domain name, and its a unique Oracle Cloud identifier. On the left are links to resources available for the VCN. It defaults to listing any subnets created, but we can see there are none created yet. We see some resources have the number 1 in brackets beside the name, which indicates this resource was automatically created when the VCN was built. We see a Cider block, route table, security list, and DHCP options have already been assigned or created. The VCN automatically gets a default route table, security list, and DHCP options setting, but it does not include any default subnets. We click on DHCP options and see that the default options have been set, and the DNS type is Internet and VCN Resolver. We click on security lists. Oracle Cloud Infrastructure provides a default security list to manage connection traffic in and out of any subnets associated with the VCN. Clicking the security list name, we see there are 3 stateful ingress rules. There is a rule for port 22 supporting SSH connections to the instances attached to any subnet of this VCN. There are also 2 additional rules supporting ICMP for internal communication. Clicking on egress rules, we see there is 1 stateful rule supporting all outbound traffic for all protocols on all ports. You can find out more about working with security lists from this video, which is also available. We click on MOR VCN99 in the breadcrumbs to return to the VCN details page. Now we click Route Tables under Resources, and then the name link Default Route Table for MOR VCN99. There are no rules until they need to be created for their specific purposes. We return to the VCN details page by clicking on its name in the breadcrumbs again. We click the Subnets option under the Resources. As stated earlier, there must be at least 1 subnet created in order to support the creation of instances that want to use this VCN. To create a subnet, we click Create Subnet, and the Create Subnet dialog appears. We give the new subnet a name, I will call it MOR VCN99-SUB01. We will leave it associated with our current compartment. The default subnet type option is a regional subnet, which is useful for high availability across multiple availability domains. However, for this subnet we select Availability Domain Specific. This option is useful for creating a more isolated subnet. From the Availability Domain drop-down, I select Availability Domain 2. Next, we input the Cider block for IP address assignment for this subnet. This contiguous Cider block must be within the range of the block specified for the VCN. We will provide 99.0.2.0/24, which provides for 256 IP addresses. From the root table for our compartment dropdown, we select the default root table name. It is possible to change the compartment, and then we are offered to choose a root table from that compartment. If we don't make a selection here, it will default to the one created for the VCN. For subnet access, we select Private Subnet, which means instances on this subnet cannot directly access the public internet. There is the option to create a public subnet, which will allow for public IP addresses to be assigned to instances using this subnet. If we allow for DNS resolution for the VCN, then a DNS name can be assigned to any instances launched which are attached to this subnet. And like when creating the VCN, we can choose a DNS label or leave it to be the subnet name. Clicking the DHCP options dropdown, we can choose a different default DHCP options by changing the compartment and selecting a different DHCP options name, but we will take the one created when we created the VCN. If we don't make the selection here, it will default to the one created for the VCN. For security lists, clicking on the dropdown, we can select the default security list created for the VCN to manage traffic in and out of the subnet, or change compartment and choose a different one. Clicking the Another Security List button, we can add up to 4 other security lists available in the compartment. Remember, the traffic will be managed against all the lists that are added. Again, if we don't make a selection here, it will default to the one created for the VCN. We will ignore tagging options and click Create Subnet. After a short pause, the subnet appears on the list of subnets for MOR VCN99. Additional subnets, both private and public, can be created as necessary, each with their own particular set of resources. Under Resources, we click on Cider Blocks. We see the current Cider block configured for the VCN. Clicking the Add Cider Block button opens a dialog which allows us to add a new IPv4 Cider block to the VCN. Remember, the block ranges cannot overlap, and there is a total maximum of 64,000 addresses. So it's important to plan the block ranges. We don't need another block, so we click Cancel to close the dialog. Clicking on the 3 dots menu beside the table entry gives us the Edit Cider Block option. Making changes to the block must be carefully considered as there may be many components associated with the VCN. Also, with more complex VCNs, it could take some time to carry out the changes. The Add IPv6 Cider block allows to create a block of IPv6 addresses. At the top of the VCN Details section, there is a button called Move Resource. Clicking on this button opens a dialog allowing us to move this resource to a different compartment. Clicking on the Choose New Compartment drop-down allows us to select a new compartment and then click the Move Resource button. We don't want to do this in this demonstration, so I'll click the Cancel button to close the dialog. That's the end of the video. Thanks for watching.